Okay, hi and welcome to the note video on operations with radical expressions. Again, specifically more than one radical term. So you can see here in example B, we've got two radical terms. What can we do with it, and how do we make sure that it's simplified? Remember that a rule says if the radicand, or the value underneath the radical, is this exact same, that they can be combined as like radicals, and the coefficients will add or subtract depending on whatever their sign is. So in this regard, these are like radicals. So what we're going to do is we're going to take off and address the coefficients of both of these. There's a -3 and a -4. The radical then comes under one radical that's combined as the square root of 5. We're combining them together because we're adding like terms. Very similar to how we would treat variables, or x's or y's or whatever ones that were similar. So we're going to go ahead and combine -3 and -4. We're going to get -7, or -7 times the square root of 5. And that one would be as simplified as far as possible because our radical 5 is not have any more perfect squared terms. Let's check another example here. In this next example, I can see right away that I do not have like radicals, so I cannot add them together as is. However, being clever, we realize that this 20 can be reduced. So if we take 20 and look at it as 4 times 5, right? Let's clean that up. 4 times 5 then is going to be the square root of 2 squared times 5. Again, all under the radical. And the reason that we wanted 2 squared is that that is going to reduce out because those are inverses and come outside of the radical. So what we're left with is going to be that 2 that comes out. I'm going to scoot this down a little bit, and the square root of 5. So that whole piece changes to 2 times square root of 5. What does that mean? Well, it looks like this. It's going to be 2 times this 3 that's there times the square root of 5, plus our 2 square roots of 5 drops down. All right, so now that we have that, we'll take 2 times 3, which is going to be 6 square roots of 5, plus 2 square roots of 5. Now we have like radicals. The radicands are the same. So now we can add these two together, again addressing the coefficients. They're going to add together both positive values. That's going to make 8 square roots of 5. All right, let's look at one more example where this time we're going to employ the multiplication with multiple radical terms. So again, distributive property is going to take place here. We're going to take the square root of 2x and multiply it to both of these terms underneath the inside the parentheses here. And so we're going to get the square root of 2x times the square root of 6x minus, negative drops down, subtraction sign as well, 2x times 11. All right, so let's clean that up a little bit. Let's put these under the same radical. So we're going to end up with 2 times 6 times x times x. I'm going to go ahead and leave those separated so you can see that I have all of the parts of those terms there. Subtract, or minus. This is a whole value. It's not underneath this radical, so we're going to move that to the front. So it's going to be 11 square roots of 2x. All right. So now that we've got that, we notice that this 6 is going to break up a little bit here, and we're going to be able to make a perfect squared term. It's going to break up into 2 times 3, and then I'm going to combine it with that 2. So there's one of the 2's, 2 squared, and the other 2 that came from that 6 multiplied by the 3 that's left over, and I'm going to combine these together to make x squared. Now the reason I did that is so that I've got perfect squared terms that can come outside of the radical. So this square root and that square are going to cancel, that 2 is going to come out, and this square root and that square is going to cancel, and that x is going to come out, leaving me with 2 and an x out front. Again, both of these two terms here, they've been released. Underneath the radical stays the 3, so it'll be times the square root of 3 minus 11 square roots of 2x. Now, this question's great because it makes you really think. You see a 2x here, and you see a 2x here, and it's supposed to be there to maybe even fool you if you don't know your rules. However, you're super smart, and you're in my class, so you know what you're doing. And you understand that these radicands here are not the same. So these two terms are not like, or they're not like radicals, so you cannot add or subtract any farther. You're actually done at that point. All right. Thanks for watching the examples. Make sure if you check out the note video. If you happen to skip it, go back and watch it. It's worth watching, and you should be ready to do some of this in class. We'll see you then.